Hey there, this is Seth Juarez from Channel 9 coming to you from NDC Oslo. I am here with a special guest, the one and only Michele Bustamante.
Hi.
Did I say it right?
You did.
I know.
Well, you habla español.
We should just do it all in español. Vamos a hacerlo todo en español.
Sí,
Ella habla
yo voy a hablar muy mal porque yo no hablo muy bien.
¿Qué va? Se entiende muy bien. We'll do a little
Él habla
English.
mejor.
¿Qué va? So we'll start a little English because there's people that are like,
Vamos a hacer clusters.
yeah, we're going to make some clusters. So why don't you why don't you introduce yourself, tell us who you are first so that people know who you are.
So I'm Michele Bustamante, and I have a consulting company called Alliance. So we assemble teams around projects. I run a microservices and security practice. We have other data practices and things like that. And what we do is we bring together experts in the industry across all the things so that we can de-risk projects around those types of expertise. So for example, big data, machine learning, cloud, various cloud features, containers, security, all the things.
So we're going to talk about containers today, but we're just not going to talk about it. We're actually going to make something. So why don't you describe really briefly what we're going to do, and then we're going to put some stuff in the oven to like bake,
We need to bake some stuff in the oven.
All right, so let's, like a 60-second, what are we doing?
Okay, so we're going to create a DCOS cluster in Azure. So it's an Azure Container Service cluster. And then we're going to deploy some stuff to the cluster.
So what's DCOS? Is it like a container orchestrator?
Data center operating system. This is the Mesosphere platform for container orchestration. Azure Container Service supports Kubernetes, DCOS, and Swarm. There are other platforms as well. I mean, we can use Service Fabric as an orchestration platform as well, and that would be also where native, managed components like Service Fabric can provide, as well as containers now. And then there's a handful of others, like for example, Amazon native or Docker native, which would be the Docker Enterprise Edition. Okay,
so let's get in there. Let's make one right now.
We're gonna make a cluster because we got to let it bake. So we're gonna say container settings, and we're gonna choose an orchestrator, DCOS. And it says sponsorship, good. Gonna create a new resource group, DCOS2, I'm gonna call it. And I need to do this in East US, I believe, for this to be happy with me. Let me go select something that works.
Very good.
And we're gonna say, okay.
And so this is gonna get started, and it's gonna take a little time.
Glasses for this one, so
Well, no one can see because it's pure computers.
Right, so I'm gonna say DCOS2. This is just going to be my, prefix for stuff. I'm going to have credentials, DCOS admin, but I need a public key to put here. And this is why we're recreating this now, just to show all the things you can do. So right now I have a .ssh folder in here, and I got a key like I can cat acs.pub. And what I'm going to do is grab that guy, okay? So we're going to grab this, but we got to be super careful how we do it, because if we mess up...
There's a way to do, you can cat bar copy.
Probably, but you want me to do that now?
No, I want to make sure.
Yeah, well, I'm going to make sure by just, backward spacing and stuff. So I'm going to paste this, and we're going to make sure we don't have any spaces and things. And we're going to scroll up and make sure we don't have any stuff. Yeah, it looks good. So that should work. And I'm going to just say, okay, let's go. So that will allow me to securely tunnel in to the cluster once it's been created. And I'm going to say I want an agent count of 3. Why not? And we'll just take the defaults here. And we're going to build that cluster. So this is now doing a validation. And of course, I have the private key already in that folder. So once this is created, we're going to be able to do stuff.
So it's going to take a little bit of time to do that, right?
It's going to take a little bit of time. So we should let that bake.
Can we go back, and while you're setting this up, there was a couple of questions I had about DCOS that maybe you can answer. So we'll go back and fake create. We won't create it.
Do a fake create?
Yeah, we want to fake create so we can
And let's go to containers.
And we're doing Azure Container Service.
Azure Container Service.
Okay.
And we'll click Create again, Fake Create.
Fake Create.
And we can choose, for example, the orchestrator.
And the orchestrator is just the kind of orchestrator you have. You have DCOS, Kubernetes, or Docker Swarm.
Right.
Okay.
Right.
And so that's easy. So let's pick DCOS like we did before.
Okie dokie.
And we'll do that. We'll create new, blah, blah, blah.
Demo.
Because there was an aspect of, there was some things you could toggle that I wanted to ask you about.
Okay.
So let's go okay.
All right, so we're partway through.
So what's the DNS prefix? Is that the DNS name for all the containers that will live in there?
No, it has nothing to do with that. It has to do with the DNS for the nodes I'm creating.
Okay.
So, without mapping, DNS for like my own subdomain or whatever, I'm going to get some DNS out of Azure, and it's going to be prefixed with this, and then it will generate some nodes with that prefix. So I'm going to have a master,
I see.
and I'm going to have some agent nodes.
Oh,
So normally
okay.
you have a master or 3, let's say, usually 3, right? So there's a master cluster, if you will, and that's what tracks the health of all the agent nodes. The agent nodes is where you actually deploy your stuff.
I see.
And, once you've got actual containers deployed to the agent nodes, and in the case of DCOS, there's public and private agent nodes.
Okay.
The master knows and helps to monitor the health and status of those
everything
nodes, how much CPU we're using, how much memory we're using, and you'll see that when we tunnel in,
Right.
to the DCOS.
Okay, so that I understand. And the master count is how many master nodes there are?
Right. So I'm doing obviously a cheap version to
Right.
not spend too many
Yeah.
points, but usually you would have a minimum 3 because it should be clustered.
So there's redundancy there.
Yeah, exactly. And it's usually uneven, so 3, 5.
So are you doing quorum voting or leader election?
It is, and it does leader election for the master orchestrator. So basically, yeah, we're using the Mesos platform here, but like if I was on a Swarm cluster, then I would have Swarm running and Consul running, for example, on the master. And in the master cluster. And then if I'm using Kubernetes, then it's going to be,
Okay.
Yeah, exactly.
And then the last question, which is the next one, is the agent count. And what do the agents do, and how is the master related to them?
So the master monitors the health and status of your agent nodes. Your agent nodes is where you deploy your actual containers.
Okay.
And so, again, each of the orchestration platforms has their way of doing things. For example, out of the box, DCOS gives you the concept of public and private agent nodes.
Okay.
So that means my public node would be where I'd have a public load balancer with, HTTP access to my
and
web
port
tier.
80 would be open, for example.
Exactly. And then I have private nodes where I might put Kafka,
Middleware.
Packages or Elastic packages or other things that you would not actually want to reach directly normally. But within the cluster, the master and all the nodes have open communication with one another because they need to have a heartbeat.
That's also, for example, if you want to do really powerful caching, you would have a private node that's actually managing the cache.
Right, and you can get more sophisticated than the templates give you out of the box.
Right.
Where you might structure several layers of different types of nodes, groups of private nodes and public nodes. So that gets more complicated, obviously.
Of course. So once we've done that, so generally you would have more than one master to be safe, and then the agents are the things that create the actual containers. Did I get that right?
No, you deploy to the nodes.
And the agent nodes?
So what happens is, for example, let's just kind of go back to basics with Docker.
Yeah,
right?
let's do that.
So if I want to, compose up, I would have a YAML file. The YAML file would describe one or more services and characteristics of the service requirements, memory requirements, CPU, etc.
The images that you would pull,
The images you would pull, but it also might, for example, in each of these orchestration platforms, describe additional assets of the platform. So for example, when I want to stitch up to a public load balancer in DCOS, there are properties in the YAML equivalent, right, which is the task definition.
Got it.
Just like you'd have a task definition for Kubernetes, right? They each just have different lingo for describing kind of the same thing,
right?
Which is describe what the requirements are of the container or a collection of containers and how they compose together and what their runtime properties should be. Could also be minimum health requirements. Always have 2 running, never expand to more than 4 at a time.
Or CPU needs to be below a certain threshold.
Exactly, and those are the kinds of things that you want the master to manage or orchestrate as part of scheduling deployments.
Got it. So my confusion is, what are the agents like separate containers that their job is to, what are they doing? Like I'm confused about the agent nodes. What are those things?
So when I tell the master to deploy, it schedules the deployment of my, say, web container to the nodes. So if I ask for 10 and I only have room for 3 because I'm asking for 1 CPU each and there's nothing else left, then it can't schedule all 10. It will schedule 3 and the rest will wait and be pending.
And the agent is the one that's actually managing when these things are going to happen.
The master is managing scheduling to the agents. The
Okay.
agents have the resources available, and they will, publish availability to the master.
I
The
see.
master
So,
says,
okay.
where do I put these services?
I see.
Where do they fit?
So the agent's the machine that houses the actual containers, or
Exactly.
the virtual machine that has the actual containers. It
Yeah.
says, I have space for 5 things, I have space for 3,
Right.
and you might have rules that the master needs to say,
Or it actually more likely says, I have this much space,
Mm-hmm.
memory, CPU, disk space. And there could be other things like ports, other
Yeah.
types of resource constraints. And your deployment, scheduled by the master, the cluster,
Right.
the orchestrator, it will figure out,
where to put them.
where can I put this stuff?
And you might even have a rule that says we want 2 of these containers and they must be on different agents. That might be a
You can
request.
do that.
And
You
that
can
might be
co-locate
and that
as
might be a request, or you might
you
say
can pin it to
yeah.
the public or private
Yeah,
nodes, for example.
and that's interesting because now the master, when it says I need these type of containers need to live together, these ones need to be like apart, and then the agents will say I can't do that, and then it has to wait, or I can do that, and here's the result of that.
Right.
Okay.
And we have liftoff.
Awesome.
So
looks like we
DCOS
talked through it.
2,
Yeah.
And if I go into my resource group, you'll see this is what it created, right? So there's the container service.
That's a lot of stuff it made.
Well, it's got, the master nodes, the
Agent nodes.
agent nodes, and so on. So if I kind of come in here and I say, okay, let me go find my load balancer. So what I'm looking for is my IP, actually. Public IP address of
There
the
it is.
master.
Oh, yep.
So that'll give me my DNS that I need to hit. So right now, DCOS2 management.eastus, right? That's my DNS. So I'm going to hit here. And I'm going to go. So notice, I have my ACS dot key. So what I'm going to do is I'm going to edit my tunnel for SSH. So what I'm going to do is change this. So I'm going to be tunneling in at port 4555
To the DCOS
to
master.
the DCOS master. And I'm going to use ACS.key as my credential. DCOS admin is my username I provided. And what was this? DCOS2 demo?
Yep.
Demos plural? Or DCOS2 management?
I think it was DCOS 2.
Okay, so that should be it.
Oh wow, you got a VI real fast. I mean, usually it would have taken me several.
Yeah.
Yeah.
Okay. This is what I was running into before.
Okay.
Because you got to have a key that works, and I didn't create a new key, and I thought that was a good key. So, we may have a problem, Houston, because if you don't have a key, you can't get in.
Right.
So what I wanted to do was tunnel. And if I tunnel in, then I can actually show you the DCOS UI.
I see.
We said we'd wing it here, and wouldn't you know that something's wrong with the key that I use, so this guy is not happy.
Okay.
Which means I can't tunnel in.
Right.
So,
Is there one that you can tunnel into that's open?
if I had an existing cluster, there could be.
Okay, got it.
So
got
we
it.
may have to do that another time.
Yeah. So speaking about these clusters, so once you set these up and you've set them up right, it just happens that the key was not right. Did you go in there and change the key?
Not easily.
Oh, I see.
Right.
Because that's like one of the biggest security.
You have to be able to get in. Yeah, exactly.
So
That's
let's
like the number one first thing.
Right. So
Yeah.
let's talk about this. So
Okay.
the only different thing that didn't happen here is that we didn't do the key right, which is okay.
Yeah.
Let's talk about containerizing the application itself.
Okay.
Because it feels like so I had a computer science teacher said that there is a way to do sorting faster than n log n. And he's like, but it works on really large data sets. And if you're trying to sort like a 10 item thing, that's like shooting a fly with a shotgun, right? And so sometimes when I look at these types of containerized applications, I'm thinking, here's the shotgun,
Right.
right? Like,
Right.
how do I know when I need to get to that shotgun
So I think
level?
what you're really talking about is, do I need an orchestration platform?
When will
What
I
are my
need it? When-
options for working with containers in general?
Right.
So if you think about the many uses of Docker in general, from a development perspective, it's hugely beneficial because I can create an entire environment and compose up and have it, like spin up things that normally I wouldn't want to install to my machine, right? So I could have things like I'm working with Kafka,
right.
or I'm working with Event Store, or I'm working with, local SQL development, and I just want to spin up the schema and all the things that all my developers need, and I want to get them up and running quickly to work on the project. I don't want them installing this and this and this and this. And plus, people don't want to do that on their main machines.
Of course they don't.
Because it's complicated if you work on lots of things
Sure.
too. So, Compose Up allows you to really quickly spin up dev, test, even test automation environments. So that's pretty cool. Now, of course, that's just development, and sometimes people use it just for that.
Right.
And then we've got the concept of I'm a startup.
Right.
I just want an easy way to do works on my machine, put it somewhere, still works.
Right.
So even though I could have just deployed a website to, like, say, an Azure web app, if I use a container, and then, again, it's completely immutable.
Right.
And repeatable, and it works here, and it works there, and I can give it to someone else to say, can you run that and do X, Y, Z? And we know this is the image that finally worked, and we're going to put that up in our 2 redundant websites or VMs in the cloud. And I'm going to need to open the port to get to it, and I'm not going to have dynamic port discovery. So it's going to be literally one on each machine, right? Because I can only use the port once, so nothing fancy.
Right.
But I know startups that are really excited to use Docker that way because of the works on my machine, and because when they need to fix something, they can actually get the container, edit something to fix a problem, and then save that image as a new image, as a baseline, so that they know what's in production now.
So
it's kind of an interesting sort of poor man's works on my machine and works everywhere story, right? And that's the lightest weight version that you would use. But again, I know people that do that, love it, automate with, Ansible to push things out, and that's their little process.
At what point do you go from containers to you need an orchestrator? Do you see what I'm saying?
Right.
Like there's going to be a time where it's like, yeah, I just put out my 5 containers and they're happy, and I have a really good build script, and I'm using Octopus Deploy to do these things really a nice way.
Right.
At what point are you like, okay, we need to move into orchestrator realm?
Well, so again, I usually work with larger enterprise solutions. And so, I mean, as soon as you get into a situation where you've got distributed teams, multiple teams, you need that dynamic discovery, even that dynamic burst or scale. There's different types of scheduling patterns, too, that you might need for your services. Like, some of them might run like a job, right? Like, it's scheduled on demand, and it's going to go pull some things from a bunch of locations and do work and then go away, which means the scheduler can find resources available, queue, finish, queue more, and then suddenly go away. And as long as you have a bit of spare resources on your cluster, you can do jobs of stuff, and then they just kind of go away, and that's nice, right?
Yeah.
So that's one model. And then I've got a web app or a web API, and it's always running.
Right.
But sometimes I need more instances because I've got a burst. So there's 2 layers of scale now. There's density across my cluster, and then there's I need more nodes. The physical nodes scale second.
Right.
And so, the first stopping point is let's fill the machines, handle the load, and then scale back down. And that's something the orchestrator can handle for you to the point of pushing the nodes to their full density.
I see.
And then, of course, when you reach a certain level, you're going to have metrics that say, oh, I'm at 60% CPU. That's risky. Let's go ahead and add a couple more nodes. And that's where your, Azure or cloud platform should auto scale you.
Right.
Or you have a model for scaling, right?
So when you say nodes, you mean agent nodes?
And now I mean the agent nodes,
Perfect.
Exactly. Yeah.
Okay, so I am understanding this now.
So there's these layers of scale that you now get a piece that's part of the software and the orchestration. And then there's another model which is interesting, and that is when you do message-based systems. So this is my favorite thing because I did a talk on that here, and that is any sizable containerized solution, microservices, can benefit from visibility. You're going to have a bunch of little things running around, more than usual.
Right.
You need to know where they are, how they're doing, how's their health, that they will self-heal. The self-healing and so forth is handled with the orchestration platform.
I see.
And so there's health endpoints that are monitored, and then if this container fails, it will restart it. And it will continue to try to restart it until well, you tell it to stop doing that, or it succeeds. And so that's called flapping. And so the flapping concept is actually useful because it's a way of seeing you have a problem very obviously, right?
Yeah.
So for example, let's say I'm reading messages from a queue and I'm all message based. So now all my messages that call APIs to do work have essentially, I now have a full audit of all the things that ever happen. Every single API in my system is called through a message. And every single message is, recorded in my, Kafka or, Event Hub, or Kinesis. And I can keep those messages forever. This is an asset. And I can use those messages to not only project an eventually consistent read-only state for my my reads. My writes become the messages. The messages are actually the system of record now. That's called event sourcing. And then at the end of the day, my eventually consistent reads can evolve. I can start with what I think I needed, and suddenly I realize I need an aggregate or something else. Oh, let's replay those messages and build an aggregate for that service. Oh, and let's read these 3 topics and pull that into another aggregate for that reporting service. And now I've got data that I can repurpose from the source, the origin, which is the source of truth, which is these are the events that happened in the system. User was created, user logged in, user got locked out, user was re-enabled. It's true data. It's what happened.
So does that become like...
So it's a visibility thing.
Now is that, because when I've used, like, for example, message queues, when I pull stuff off, it's gone off the queue. Are you persisting these somehow in order to maintain history?
You are, yes. So pulling off the queue is more of a pub sub sort of, traditional. When you think about, Event Hub, Kinesis, Kafka, they keep messages for, say, 30 days. And then, of course, there's an archival process.
Sure.
But that 30 days is a long time. And you have multiple consumers that can be at different read points in that queue, if you will. So when you say you've read it, you're not taking it off the queue. You're taking it off your consumer cursor.
Oh, I see.
So it's still there. And this is really powerful so what I was talking about with scheduling services, that's a totally different type of service, which is like a projector that it should always run, but you don't care if there's only one, because if it dies because it can't read the queue, something's wrong with configuration, really bad. Oh, I can see there's a problem. Let's fix the config. Now it's starting to work again. Messages are firing. So it's a whole nother scheduling perspective, which is a thing that can fail fast.
I see. And now this is where, when moving from a monolithic application to a containerized application using orchestration, becomes like you have to think a little bit differently. Because before it was like everyone's calling the database from some middle layer thing. Now each of the containers is supposed to be independent of one another. Is that right?
Yeah, and what microservices promises to solve is the thing SOA didn't. Okay, which is, of course, it's work, right? You have to design this. But with SOA, we couldn't really truthfully go through a service boundary and own the data behind the service because we had these cross queries, relations, and how do you do that through a service boundary without performance hits and issues? But with microservices, the idea is that each service is more granular, holds a finite amount of data, but when you need the aggregate, when you need to combine data in different interesting ways, if you go to a message-based model, then that source of messages now becomes information that a different projector can read to produce new views of the same information. So now I can truly say I'm eventually consistent, across all my services. So create a simple example, create a user. I create a user, I register, which means I want to register, but until that message is played, we don't know if I could lock the email address or the username. So that could fail or succeed. So another message for failure is produced, or a message for success, and a confirmation message comes in to send me my code for confirming my email is accurate, right?
It's almost like a ledger for your
It's a ledger. It's exactly that.
Yeah.
It's exactly that.
And so you're able to, like, accounting-wise, see what has happened in your system.
Right.
But this requires a completely different way of thinking about applications.
It is, and the thing is the key, in my view, is you keep it isolated to the microservice boundary. A microservice fits in your head, right? It's a manageable amount of logic feature that is hopefully aligned with the business that wants the features, and then that information is a finite amount of data that you care about, a finite number of messages that you care about, and those messages, even though it feels like an overwhelming thing to do, the first couple services you create, you get your patterns. Oh, okay, here's my plumbing for dealing with, registering messages and handling messages and processing messages and activity IDs and things like that that correlate messages. Once you get that baked, the rest is manageable because you're only thinking about one service at a time. So it becomes interestingly easier than you think. Now, I'm not saying it's easy. Of course it's not. There's things to think about. But I'm lucky, right? I get to work with people that do this stuff all the time when we work with customers. So collectively, we all bring our knowledge to the table. So I guess the key is to hopefully get guidance,
Right.
and that way learn that first path yourself and then take it and run.
So my confusion happens when, and you're probably going to be like, yeah, it's because you've never done this before. But when there's two for example, I'm always thinking, because I taught database theory, I'm always thinking in terms of relationships. But for me, a container might deal with logically, and it's not maybe one table, but maybe it logically deals with just people.
Right? An aggregate. So
yeah.
in domain-driven design terms, it would be a microservice only deals with its aggregate.
Yeah. And so this would be, for example, people. But now there's another service that deals primarily with, say, for example, where they live, because it does some certain operations with zip codes and whatever.
Right.
How do these things communicate in a good way? I keep hearing this notion of messages, but if I have another service that's supposed to aggregate those things together to produce a view of a map, for example, for that person, how do I get that data together?
Right, and that's where you have to think about where the data is coming from.
Right.
Is this an aggregation of multiple sets of messages from different things that happen? In which case, I might have a global topic that funnels messages to microservice topics, and then I can have projectors listening on the microservice topics to handle their only view of the data, like the read-only projection, for example, the current state. And then I can have another projector that reads multiple topics and aggregates those and turns it into another read-only or eventually consistent view.
Okay.
And now I've got just these different things reading from the queue. Now, the whole idea of things like Kafka and Event Hub and so on is that they're built to scale. They're built to handle IoT messages flooding from all over if they're partitioned correctly. So, you should be able to handle all that from a global, ordered, you can even enforce global order, really, if you use your topics the right way. And
so I'm going to walk through what I just heard in the example, because I want to make sure I understand this. So a bunch of messages come in. A message comes in, this person was created.
Yeah.
The microservice that's a message that is the person one will take that message and say, okay, now I have a person that I need to be aware of. And then another address comes in. And the address service is like, oh, here's an address that belongs to this sub ID 256789.
Right.
As soon as those two messages come in, the one that actually is in charge of drawing the boundaries is like, oh, I have a person, but that's not interesting to me. Oh, I have a person and an address that are related. Those are interesting to me. Now I'm going to do my work.
Or the address writes the address and has the full information about who it goes to. And once it's written the address, fires a message that says associate address to person. And then that becomes another message that comes in through. So, and the key is a message should only originate ever from one source. And if you follow that rule, then you have your boundaries and your microservice perspective around who owns which messages.
Would you say that then we're shifting data storage from the database, from relations, into this durable message store that has in aggregate a ledger of what's happening. So if everything were to completely explode, you can rebuild everything by replaying
That's
it.
the idea.
Okay.
But again, that's, you can go full-blown event sourcing whereby the messages are the system of record.
Okay.
In which case you might be using products that actually support that so that you can query the message store and dynamically fast forward to a spot or snapshot and forward from there. But with things like Event Hub or Kafka or Kinesis even, like those types are not meant for that per se.
I see.
You would have to build your own fast forward. So instead what people would do is really look at the eventual consistency model, which still means the messages are a source of truth that you could go back to because you will archive them. They are an asset. But perhaps you shouldn't have to go back to the archive unless you need to rerun your logic on how you build your state.
Got it.
In which case you have that option, which is great because if you mess up, you actually have a way to go back and fix your mess up. Not that it's not work, of course it's work.
Sure.
But the fact that you have the data is half the battle.
So in that case, the person, for example, microservice, would have its own persistence mechanism. Once it received the data that it needs to do its job, it would persist that. And then let's just say that persistence becomes corrupted. You just replay the messages so that it gets into the right state.
Rebuild.
Okay. So I think I'm starting to understand it. We've run out of time, though, which is a bummer.
I know.
This is amazing
we should
stuff.
do this again and actually do a
Absolutely.
dynamic DCOS
Absolutely.
demo.
And this is really interesting to me because it's like I understand the value of doing this, but the limit of my understanding lies at here's the value. I know why it's great. I know that you can do a lot of things and that it's going to self-heal and it's going to be very expansive. It can be scale as large as you want. But my problem is, how do I write these the correct way?
Right.
Because you could shove monoliths into DCOS and it would work just fine.
Yeah.
But it's like, hey, you're using a shotgun for something you shouldn't.
Yeah. You have to need it. I think the thing I would leave you with is this: if there's no business driver for investing in moving towards microservices, full-blown orchestration platform, and messaging, then you're going to fail because the business won't support you because it's going to be expensive. Your first launch is expensive because you need disaster recovery, DevOps, visibility, logs, audit. You need to know I can recover from failure and manage all these moving parts. So your first 5 to 10 services you go live with, super expensive. So if you don't do a high value business proposition in that first launch, it will not be supported by the business later. So look for that first, and then you will see that going from that to adding more becomes more manageable.
In your experience, do you find people like already have an application and meet the limits of a monolith and are like, our business requires that we move to this, and that's when that usually happens?
Well, usually it's more of a business problem. We can't track workflows across all the systems we run. I have no idea why that data is bad, what happened over here, where we're at here, and we're wasting human time, effort, research, forensics to figure out problems.
Got it. All right, well, this has been super informative. This is super helpful. The always intelligent Michele Bustamante educating me on DCOS and actual containerization. I love the idea about messaging. I'm going to have to look into that more. Thanks so much for spending some time with us.
Thank you.
Thanks so much for watching. We have some really important guests coming up next. John Galloway and James Montemagno are going to talk about the .NET Foundation. We'll see you after this tiny break.